One of the few benefits of working as a dishwasher in high school at a supper club was that when I finished work, I could go home, sit on the back of my car, and gaze at a full display of the night sky. I could see a whole array of stars, even a strip of the Milky Way. But by far, the most beautiful part was being able to see the stars sparkle, ever so slightly. Little did I know this sparkle would turn into my entire PhD research project. Because while aesthetically pleasing, this sparkle causes major problems for astronomers. As light passes through our atmosphere, it is bent and tossed around in the same way a plane is jostled in a turbulent storm. This serves to blur our images taken by ground-based telescopes, which is catastrophic if you're trying to see a small planet next to a distant star. My research is focused on developing 2 new prototypes to help combat this blurring effect and open up these new avenues of scientific inquiry. Now, there is a partial solution called adaptive optics, which is a machine you place onto the back of a telescope. However, it's only a partial solution because it only works for some kinds of light, including infrared, which is the light you feel as heat on your face on a sunny day. However, adaptive optics is not a current solution for visible light. And you might ask me, Sam, hold on. If it works for infrared, why can't we just take what works there and do that with visible light? And the answer to that has 2 parts. 1, accuracy, 2, speed. Visible light is extremely restrictive and picky. It demands you are both highly accurate from a mathematical sense, and you run extremely fast. You can think of an adaptive optics system producing an image as an artist making a copy of the Mona Lisa. The more time you allow, the more detail that can go in, the better the final result is going to be. Now, with visible light, take away the artist's nimble paintbrush, hand them a broad stroke makeup brush, and tell them to finish in half the time. So, we need new technology in order to keep up with visible light's demands. I am working on 2 prototypes. Prototype A is extremely accurate, but runs rather slow, and prototype B, which runs extremely fast, but has imperfect accuracy. Therefore, I'm testing 3 solutions. Number 1, I can speed up prototype A. Number 2, I can improve the accuracy of prototype B. Or 3, I can cleverly combine the 2 into 1 so that we get the benefits of both at the same time. This would serve to remove the blurring effect from our astronomical images and pave the way for a lot of new and exciting science. My research was perhaps best summed up by my parents. When I told them what I did, they looked at me in near shock and horror and said, "Sam, you are quite literally taking the twinkle twinkle out of the little star." Thank you. Thank you.
All right, so Sam, I read you're from Door County, Wisconsin.
Yes.
What is a local tradition or food that always makes you think of home?
An old-fashioned, for sure. That's a classic supper club Wisconsin drink.
All right, so for those of us not familiar, talk to us about what a supper club is.
A supper club, there's always a bar and there's always a dining area, and there's a very specific order. You have to go to the bar first, or you aren't accepted as a true citizen of Wisconsin. And then, once you're ready to order, you move into the dining room, and it's normally very generous portions.
Very good. Awesome. Congratulations.
Thank you.